Although much of the interlocking on British Rail is based on electromechanical systems, computer-based interlocking is also being introduced. The Railway Technical Centre at Derby, just a few miles down the line from Leicester, is where much of British Rail's research and development work is carried out. In the labs here, they can put the interlocking through exhaustive tests before it's installed on site, so that they can be sure it satisfies their rigorous safety requirements. The screens here give a display of the track layout, showing points, signals, and track circuit sensors. This layout is for part of the main line near a station. There's a cursor on the screen, and the engineer can set points and track circuits to particular states, and then see what happens when routes are set. This is part of the formal testing procedure, and so it has to be carried out rigorously. To make certain of this, the engineer has a list of the different tests which have to be carried out. The list is prepared to check all possible states of the system, so that there can be no surprises when it's installed. Here, the engineer is setting a route which starts at signal 36. When the route is set, the signal turns green. If the engineer changes the track circuit to show that this line is occupied, then the signal turns red. The software which controls the interlocking contains a large number of conditions, one for each possible route. Here's the condition for the route from signal 36 to signal 34. 3 track circuits have to be clear: T21, T26 and T27. In addition, 2 sets of points, 211 and 212, must be available to be set normal. For these points, that's straight ahead. If all these conditions hold, then the actions can be carried out. Points 211 and 212 must be set normal and locked there. And then signal 36 can be set clear. Once this route is set, the other route from signal 112 to signal 34 will be locked out. That's because one of the conditions for this route is that the points 211, the crossover, are available to be set reversed. And this condition can't be satisfied, because those points are locked in the normal position. So this route can't be set at the moment. As the use of computers becomes more widespread, the railways plan to give VDUs to their signalmen to replace the wall displays. In the signal box at Leicester, there are VDUs as well as the wall display, so that signalmen can learn about the new systems. To ease the changeover, the graphics display is made to resemble the wall panel as closely as possible. The track is shown in grey, with routes set in yellow and occupied track in red. But with the use of computers, there are other facilities which can be included.
Calling at Melton, Mowbray, Oakham, Stamford, Peterborough, Whittlesea, March...
These days, the passenger timetable is stored in a computer. The computer can give information about each train calling at Leicester, such as its departure time and the stations where it will stop. One use is for the station announcer, who sits at the back of the signal box. At present, this computer is separate from the signalling system, but both systems use the same train codes to identify the trains. So an obvious next step is to link the two systems together and let the timetable information tell the signalling system where the trains are supposed to go.
We're now moving towards IECC, which stands for Integrated Electronic Control Centre. This brings together a whole area of signalling to be controlled from one point. It can control solid-state interlockings or relay-based systems or a whole combination of either. The information is presented to the signalman by means of a workstation which has a number of VDUs showing the track layouts, etc. Because it's based on a local area network, we can add on management information systems and ARS, which stands for automatic route setting. This will set routes in front of the trains by means of a timetable processor. We're due to install a number of these systems over the next few years, the first of which comes into operation early next year.
This is the console which will be used to operate the first integrated control centre. At present, it's being tested. But by the time you see this programme, it'll be controlling all the train movements in the vicinity of Liverpool Street, one of the large terminal stations in London. There are 4 screens, which can be switched to show different parts of the track layout, or to magnify any part, or to display a list of messages about the system. Although there is a keyboard, most operations will be carried out with a tracker ball, which moves a cursor across the screen. Just as with the push-button system, the signalman can set a route by moving the cursor to 2 successive signals. This route allows a train to move across to another track. But that's information which has been entered manually. Automatic route setting allows the same information to be entered from the computerized timetable. For instance, the system knows which platforms at Liverpool Street have trains waiting. That comes from the track circuit information. The timetable can then be used to indicate when a train is about to depart. And if necessary, it can set the route out of the station automatically. It can do the same for a train coming into the station. This relieves the signalman of much of his routine work, leaving him free to concentrate on the areas where his special attention is needed. So the steady introduction of computer systems is helping British Rail to increase its operational efficiency. With these additional aids to the signalman, the track can be used more intensively, providing a better service for the passenger. But at the same time, careful design and testing procedures ensure that throughout these advances, the railways continue to maintain their very high standard of safety, the most important service of all.